All right, so the next part of our lecture here on industrial materials and the way we get our raw form for processing is on powdered metal technology and the production of powdered metal parts. Now, you are probably more familiar with this in terms of inserts and inserted technology, especially if you're in the machine in our machining program where you've been using inserts for your cutting tools. Of course, from the welder side of it or the maintenance and hydraulics and process control side, you're probably not quite as familiar with powdered metal. But we need to kind of talk about this, and I'll explain a little bit more here as far as what we've got. So, powder metal is exactly what it says. So we do take and get different types of powdered metals, and they get blended together in that powder, and then of course they're cold compacted through the use of small presses. Once they're cold compacted, we get a puck of some sort in the basic shape. These are compacted into kind of like a smaller mold that's going to give the general shape of the part as well. Then they're put through what we refer to as a sintering process, where they are heated, and of course once they're heated up and that temperature is held for a certain length of time, the bonds in those particles fuse and melt together, giving us a finished part when we're done. So this is a great way to use this. Of course, we mentioned in terms of powdered carbide as far as our carbide inserts. There are a lot of other parts that are made out of carbide for slitter shafts and cutting knives, die forms, preforms, punches often can also be made out of this type of powdered metal as well. So when we are making that, again, that still powder comes in a lot of different types of ingredients. The particles are very, very small, and you can kind of see here in the PowerPoint, we're talking about particles that are under 7/1000ths of an inch in diameter. That's roughly about 2 thicknesses of the human hair, or smaller than that. So usually you get iron and carbon powder blended to make the different types of steel components. So, and they are blended in to create different types of alloys as well. So again, powdered metals are highly flammable. So as a safety precaution, you do want to be careful. Flash fires can be pretty detrimental, and of course, it doesn't take much of an ignition source to light that powder. I mean, if you think about it, think about gunpowder overall. So it's very, very flammable and has a lot of potential for damage. In that case, so you do need to pay attention and follow safety protocols when working with that powdered metal. The idea here with that powdered metal is we are compacting it to shape. So once the powder is mixed, we push it into dies, and we add a lot of force with that, and we can kind of compact that into the puck that's going to be done. Now, this mentions, of course, small cams and gears being used and made. That is pretty common. I'm going to show you some other types of parts that are used for where this is used in terms of carbide parts as well. We're, of course, using either mechanical presses to do this, so they're generally a little bit faster than hydraulic presses. So they make what we call a green compact, or what I've often heard of referred to as the green puck. And those pucks need to be handled very carefully, because at this stage they're still pretty fragile. They can kind of break or chip. Again, it is still compacted powder, so it doesn't take a whole lot to kind of knock out some of that powder. So that would be a attention to detail there, is making sure that you are not rough handling those particular pucks. The green pucks are going through a heated process called sintering. We're soaking that steel Again, the temperatures that you see here between 2150 degrees Fahrenheit to 2500 degree Fahrenheit. The soak time is anywhere between an hour to 6 hours longer. Longer time is required for lower centering temperatures. Most of these are, again, controlled processes. So depending on the manufacturer, a lot of times this is, of course, proprietary to those particular manufacturers, so they don't often let out a whole lot of information on there because it's kind of their intellectual property that they're trying to save. But just understand that this is a very refined process that is being done to these pucks to make sure that they come out the right way. As we do this centering, we do get a very dense part. So the parts also shrink. So when they shrink in multiple directions, but that also increases the density, and we don't really get too much void space in these type of powdered metrology parts, basically because that fine powder, those particles are very, very small, so it just doesn't allow for much void space in this case. This just kind of gives you a idea of what the furnace centering is all about, where you've got your green pucks kind of going in. Again, it's controlled with doors opening and shutting. There's a preheating zone, then there's the centering zone, then another door that goes out into the cooling zone. So again, it's a very, very refined process here to make sure that that temperature is held and that you get the right type of part from this. Okay, I'll just go ahead and let you read through that. So just a little bit more on the actual furnace here as we go through. Voids in our powdered metal parts can be filled to improve properties. So if we are, of course, trying to avoid oxidation and corrosion in this. So they use things like copper that helps to absorb some of this undesirable types of properties. So, and it also helps to increase the liquid flow with that. So, and as you can see, copper being put into powdered metal parts allows it to become more corrosion resistant as well. In some cases, you hear about a term called a green puck. So, sometimes, of course, copper gets that natural type of green. So I'm not 100% sure whether that's where some of the terminology comes from, but you do get that green oxidation sometimes on copper as well. All right. Notice we do control and all of this stuff, if you haven't kind of caught on, these are very, very controlled, meticulous type production standards that have to be maintained to make sure that we get the right type of properties, no matter which way we are making these particular parts and getting that raw form of our material before it gets to us. We do have to control these processes very, very tightly. All right, we're going in now. This brings us up to additive manufacturing. So we'll kind of talk a little bit about this. So 3D printing, there are several different types of printing. This particular chapter talks about laser 3D printing and the buildup of powdered metal from that. It's still kind of new and ongoing, although 3D printing has been around for well over 25 years. It was first came out in terms of being a part of the prototyping phase. So, and where we would basically prototype plastic parts and kind of get an idea before we actually went out and started making them. Now, that's in plastics, and of course there are a couple of different types of machines that do this. So I'll talk more about those in a few minutes. But right now, as we're kind of talking about 3D printing in this case, and we're talking about metal printing, again, it is a powder, the metal is powder, but now we're using lasers and laser beams to more or less apply the heat and get the deposition and the fusing of those powders together, one layer at a time, as it kind of builds up and goes through with that. Here's an example of a machine. So most of your laser 3D printers do and are enclosed to help with safety aspects. It's also there to kind of keep everything in a temperature controlled environment. One of the things about 3D printing is it is not a fast process. It is very, very slow. But you can make very, very good parts that help you to prove out concepts still. And nowadays, more and more, these parts are also being used by manufacturers to actually make parts that are more or less ready to go once they come off of the 3D printer. So some of the difficulties with additive manufacturing is we can't really destructively test every single part. So, and in the process itself, each of these parts are pretty much made up individually. So it kind of eliminates potential of reliability on some cases. So when we are talking about some of the previous processes, we can make certain assumptions for every 1,000 pieces, and we can pull apart, maybe every 100th piece or every 50th piece, and we can do some destructive testing on them. We can make some assumptions based on that destructive testing. In the additive manufacturing process, because each of these parts are made a little bit more individually, just because of the nature of the process, we can't apply the same type of rationale to the way we test those parts. So keep that in mind. That and the fact that it's a very slow process overall as well. Now, before I kind of go to the last slide and mention some of the other aspects that I kind of wanted to show you, keep in mind here at the college, we have 3D printers for plastics. We have what is referred to as STL printers, or standard lithography type printers that are fused deposition. So there's also resin printers, which we don't have. And of course, if you take some of the classes that are related to that, you'll get a little bit more familiar with those type of printers as well. Now, the one thing that I did want to kind of bring up and show you, let me pull up here another website where I'm familiar with called Vista Metals. So if I could get that up. So here is their website. So you can kind of see they do what is referred to as a carbide preform. So let's go ahead and talk about the process just so you can see. Here's some samples of parts that would be done through this powdered metallurgy. So the blending, there's testing, the engineering of the actual parts. Then they've got the pressing, shaping, sintering, and inspection from there. I've used these when I served my apprenticeship. We would get a lot of these, what we referred to as carbide preforms, that would come in, and then we would just have to finish grind them to the actual shapes. And that was used a lot for slitting shafts, cutter knives, or what's referred to as slitter knives, other types of rollers, things where you do need highly dense, very hard material to hold up. If you think about a slitter knife itself, you want that edge to be maintained, and you want it to stay sharp. So this would be where you would use a powdered metal, something like these tungsten carbide preforms, and then you would have to kind of grind them down into the final shape that you would need. So that would be one application here of your powdered metals and the use that they get.